In your textbook, lesson 9.1, and I listed the standards. Key things that we're going to be working on. I can sketch a quadratic function using the evaluated points. I can identify the x-intercepts, y-intercepts, if it's increasing, decreasing, the maximum and minimum of the function as we look at our graphs. I can explain the minimum for a quadratic. It's called our vertex. The vertex is always going to be an ordered pair. Okay, it's always going to be an x, y. We're going to start looking at that today. And then I can identify the vertex of the quadratic if it's a minimum or maximum just by looking at the equation. So, quadratic functions are functions that can be modeled by second-degree polynomials. Linear functions are first-degree, right? So remember our linear, that's when you had the general form, point-slope or slope-intercept. The y equals mx plus b, that's why you had to graph that one. We had point-slope form, y was equal to m times x minus x1 plus our y1 point. That was our modified point slope. So we are going to be looking at quadratic, and the quadratic, it says it has to be second degree. So a general form, actually called our parent function, y equals x squared. We're going to give a couple other examples that I want you to write down besides that one. So we have y equals x squared. Another one might be y equals x squared minus 4. We might have one that looks like y equals a negative x squared plus 8x minus 16. And you might have something that's just so this one is a binomial, but it has a second degree. It doesn't have a middle term or our x term. This one has all three, and this last one I'm going to give you an example of is an x squared plus a negative 4x. All of these, when we go to graph them, and when we are solving, we'll have two solutions. We're going to be referring to those solutions sometimes as the roots, you will see. They'll talk about the roots of the quadratic. They'll talk about it as the solution, and sometimes they'll refer to it as the x-intercepts. All of those mean the same thing. Now, it can have two solutions, but it could have no solution or infinitely many. So in your notes, you should have those written down. As you look at that next part, that's heavy vocab, and today's lesson is a lot of vocabulary. So if you are reading on that next part, Gavin, you want to start for us? Quadratic function?
Quadratic function is a function that can be written in any form, y equals x squared plus bx plus c, where a does not equal 0. This form is called the standard form of a quadratic function.
So these are some more examples. Could we have factored this? Probably not the x squared plus 9, but could you have factored x squared minus x minus 2? Factoring meaning could we have put 2 parentheses with it, like we did in our last unit? Hopefully so. Multiplies to negative 2 and adds to negative 1, right? We don't need to look at that right now. We are talking about a parabola. So when we had linear equations, our general form was a line. When we had absolute value, is that V shape. Parabola, so parabolic. Definition, it is a U-shaped curve of a graph of the quadratic. Now, if you make it a V, like with a definite point and not a curve, you're going to get it wrong, okay? It has to be a curve that we are looking at. So a quadratic function, ax squared plus bx plus c, where a is not 0. The reason if a is 0, then you have a linear function, right? Because 0 times x squared would give us, we wouldn't have it being to the second degree. So it says if a is greater than 0, what does that really mean? That means if a is positive, right? Greater than 0, if a is a positive number. Your graph will open upward, so you might want to highlight that. It's always going to open upward, and it will have a minimum. This is going to be key as you look at your homework. You're going to be asked, does the graph open up or down? If the a is positive, it will always open up. You are also going to be asked in your homework to find what's called this axis of symmetry. Axis of symmetry is the line that divides the parabola in half. So that they're almost mirror images. It's a wonderful thing. And then the vertex is your minimum point. And notice that the vertex is actually on your graph. It is an ordered pair. It's xy point. Differently, when we look at our, if a is less than 0, meaning a is a negative number, right? And that's the only one we're talking about. We're not talking about the b or the c. Then our parabola opens downward, and it is a maximum point, which makes sense. If this is the point on top, it's going to be a maximum. And if it goes down, we have to have a point towards the top. When we are looking at this one, again, that axis of symmetry, what's really nice, and you're going to always be asked to find your vertex first, it cuts your parabola in half. So anytime you are looking at this axis of symmetry, when I'm asking you to find that, it cuts the parabola in half. It cuts it in half. So what's really nice is when we're finding points is sometimes we only have to find the points on this side because we know their mirror image will be over here. Okay, so it kind of helps us out. It's a nice way of checking also. So, top of the next page in your notes, top of page 2, it says, find the vertex. Is the vertex a maximum or minimum? So, we're looking at all our answers. First thing we need to tell is our vertex. Okay, so our vertex is always going to be an ordered pair. The first one is at 0, what? 0, 3. Since the parabola is going down, we would say this is a maximum. And then it says, then write an equation for the axis of symmetry. Now, the nice thing about this axis of symmetry, a lot of times you're going to see me abbreviate it AOS, axis of symmetry, okay? And the axis of symmetry is always a vertical line. Always vertical. Does anyone remember, if it's a vertical line, the equation for a vertical line? Axis of symmetry. It's always x equals, right? It's always axis of symmetry, vertical line is always x equals a number, right? So when I'm thinking of axis of symmetry, I can't just put a number, I have to put x equals, because it has to be an equation. And an equation is not just one number, that's a expression. So this one, our axis of symmetry, looks to be right here. What is the x value? X equals 0. So let's do this one together, and then we'll let you try that last one. First thing we're going to start with is our vertex. Our vertex, your homework is kind of like this. It's going to be over at 1, -1. Next, this is a minimum. And the last thing we're looking at is the axis of symmetry. And that's the line that divides it in half. Which also, if you look at your vertex, it's the what point of your vertex? It's the x-coordinate of your vertex. So this axis of symmetry, once you know your vertex, the x that it's equal to, the number that it's equal to, is the x-coordinate of your vertex. So when you know your x-coordinate of your vertex, you pretty much have the axis of symmetry. You just have to write x equals with it. Okay? I would like you to try that last one. And as it says, as you're looking at this note, can a parabola have both a minimum and a maximum? No. Parabola either is going to open upward or it has a minimum point and it opens downward. So that minimum is going to open up or it's going to have a maximum and it goes down. So in this last one, please, if you have not done so already, be ready if I call on you to tell me your vertex, maximum or minimum, axis of symmetry that we are looking at. So if we are starting off, anyone want to volunteer for our vertex? Correct.
Oh, the vertex is -2.
-2, -3. And we would say then minimum or maximum? Minimum. And Dylan, axis of symmetry, x equals?
-2.
-2. Okay? All right. Now, yesterday's homework on that page 543, you might have been looking at this and you didn't have to graph one of these, but you had the absolute values. And if we are looking at this, we might make a table of values. You're also asked, going back to the beginning of the year, domain and range, right? Domain is what kind of values? Always are what values? X values. And the ranges are all possible Y values, okay? So you're going to be asked that. So first it says make a table. Pick a point for X. Now what's going to be nice is as we start doing these, you're going to see like today's equations are almost all in this nice form of just an X squared or X squared plus or minus a number. They don't have that middle term, which makes it easier. If we pick, so we're going to, a lot of times, I'm going to have you pick 2 negative numbers, 0, 2 positive numbers. You won't necessarily have to pick a half, but I wanted you to see that you can pick actually any number to get this to work. So if we are substituting in, we are going to put negative 3, and then we're going to put negative 2 in squared. Now negative 2 squared is 4, so we're taking negative 3 times 4, which means y is equal to negative 12. So my ordered pair is negative 2, negative 12. Plot negative 2, negative 12. Just by looking at the equation, do you think it's going to go up or down? What is our a value in our equation? What is our a? Negative 3, which negative 3 makes it go down. So one of the questions I'm going to ask you in your homework is, when we look at that parabola, we definitely know it had to go down because the a was negative 3, right? So now we're just going to plug in our points. So now the next one is negative 3 times negative 1 squared. Again, you have to square the negative 1. That is 1 times negative 3. That gives us negative 3. So my next ordered pair, if I'm looking at that, should be what as I look at it? What are you going to have? Our x was?
Negative 1.
Negative 1, and our y is?
Negative 3.
Negative 3. So we're going to plot that point, negative 1, negative 3. Okay. We're going to continue as we're looking at that. So Abby Medler, we're plugging in 0. What are we going to end up with? Which gives us? 0. So at 0, we have 0. And then we are going to look at 1/2. So if we were to take 1/2, Maria, I'm going to take negative 3 and I'm going to square a half. Gives us 1 what? If we square the denominator. 4. So we're going to have negative 3 times 1/4, right? Which is going to give us a negative 3/4. Right? So at 1/2 or 0.5, we're at a negative 3/4. Which kind of makes sense at 1/2. So if this was 1, we're going to go at 1/2, it's negative 3/4. So it's not quite, okay, there. And now we plug in 1. That works even better, right? 1 squared, if we are looking at that. Josie, we're going to end up with negative 3. So my ordered pair is 1, negative 3. So I'm at 1, negative 3. Oh, look at that. It's exactly symmetric, right? If we are looking at it. And it looks like our vertex is at 0, 0. And so we're looking at this last one, and what do we think it's going to come out to be? I have negative 3 times 2 squared, just by looking at my graph. It looks like it should be 2, negative 12, right? And this is exactly symmetric when I'm looking at this, right? So when I look at my graph, as I'm looking at this one, you're going to now make that U shape, okay? So our vertex, and we're going to look at each of our points, okay? So now it says, we know it was downward, we know what our vertex is. What is our domain? What are all the possible x values you could put in? All real numbers, right? You could put any x value along here. You wanted to put in negative 20, you could. You wanted to put in 0.0356, right? You could put that in. You could put in 1,525.62, right? So when we look at our domain is going to be, if we are looking at that, all real numbers. But where are our y values? What are our outcomes that we're talking about? They only go from 0 and down, right? There will not be any y values up here. So it is not all of our y's. It is just from what? Our range is going to be all real numbers less or equal to 0. And a lot of times, we wrote our range this way, where our y is less or equal to 0 for all numbers. So we might have put all real numbers, less or equal, y is less or equal to all reals, and we might have had this, right, for our all real numbers, okay? So going back to domain and ranges, right, so kind of reviewing vocabulary, minimum, maximum, and then just substituting it and making sure you are not putting -2 in your calculator and getting -4, that you have to square and use your parentheses as you're looking at those. So on the top of the next page, as we are looking at this one, it says, okay, looking at the a value. The blue equation, and you might want to write in yours because they don't have the colors. I mean, we don't print those in color. So you might want to put blue. See if I can change the blue for blue. So the blue, that is your y equals x squared. You might even want to put the equation by that one. And if you look at that, when I plug in 1 squared is 1, right? That point. When I put in 2 squared, I get 4. When I put in 3 squared, I get 9. Y equals x squared. And if I put in the negative value, same thing. When I plug in -2, I get +4. Plug in, and it is symmetric around the x equals, okay? So, next one it says, how does the a affect the shape of the graph? So, take a look at your red one, when it's 3. Take a look at the green one. Okay, so this is y equals, when we are looking at that one, y equals 3x squared. And then if we are looking at the green one, that's where we have y is equal to 1/3 x squared. And our yellow one, which is y equals 1/12 x squared. So how does the a value, affect, should be affect, not effect, affect our graph? What would you say? Please talk to the person sitting next to you, because you almost all have a shoulder partner, but you guys are going to be able to do it. Okay? What I want you to write is this. So when we are looking at those a values, okay, and instead of me, you trying to write mine, the closer a is to 0, the wider it is. I heard some of you say when a is smaller, right, kind of that fractional number. The closer a is to 0, the wider it is. And you can look at that. The 1/12 was actually much wider than the 1/3, right? As the a value gets larger, the narrower it gets. So you can imagine if I would put a y equals 10x squared, it would be even narrower, okay? So we're talking about how wide it is or how narrow based on that a value, okay? Questions? We got a few more pages in your notes, so we got to look at. We got that next page also. So this next one says, look at the c value. So again, the blue is in the middle. Y equals x squared. That's that one, not right in the middle. It's the lower. This is our y equals x squared. Then they go with y equals x squared plus 2. Then they go with y equals x squared plus 4.5. And y equals x squared minus 3, this yellow one. Okay? So this is our x squared minus 3. This was y equals x squared plus 4.5. And y equals x squared plus 2. Please talk to your shoulder partner again. We're talking about it. What's going to happen to the c? It moves to what? It moves to vertex, right? So the c determines the y-intercept of the vertex. It doesn't determine the x, right? It determines the y-intercept. So the c determines the y-intercept. When the c value changes, it translates that parent function up or down. So when it was plus 4.5, Vertex was up at 0, 4.5. Plus 2, 0, 2. X squared, 0, 0. X squared minus 3, we're going to be down at 0, negative 3. Okay? Last page of notes. If you turn to the top of the next page, and then we'll kind of hopefully get you a little bit of a start on that assignment. So you're going to have some of these story problems, and these are kind of the key of what parabolas and where we use them and how they are. It says an acorn drops from a tree branch 70 feet above the ground. The function is negative 16t squared plus 70. It gives us a height of h of the acorn in feet after t seconds. So notice t is on your x-axis, on the bottom time. It says, what is the graph of this function? And at about what time does the acorn hit the ground? Later, we're going to get really more precise with this, but to start off, you're going to plug in 0. You plug 0 in for t. 16 times 0 is 0. We're going to be left with 70, right? You're taking 0 plus 70. 0, 70. That's where the acorn starts to fall from, right? It's up 70 feet. Okay? We knew that also. So now we're going to plug in 1. And if you need to for showing your work, you're going to take negative 16 times 1 squared, well, 70. You have your calculators. Actually, you're just taking 70 minus 16 for this one, right? 70 minus 16 leaves us with 54. And 154, right here. Now we're plugging in 2. It's negative 16 times 2 squared plus 70. That means you're taking 4, right? 2 squared, 4 times 16, which is going to give us, we're looking at a negative 64, right? Plus 70. If you're not sure how I got that negative 64, make sure you go back and review over your order of operations, which means at 2 it's at 6. We're getting close, right? It's falling fast, right? And if we plug in 3, please plug in 3 on your calculator. Negative 16 times 3 squared plus 70. Negative 74. Now, at 3, is it even possible for the acorn to go negative 74 feet down if it falls off the tree?
If there's
It's
a
not
hole.
falling with much force, right? It's like landing on the ground. So, the question was, okay, so this is our graph. The question was, at about what time did it hit the ground? Well, at 2 seconds, it was 6 feet above. So what does it look like? 2 point what? What do you think? So I would say, when does it hit the ground? Between 2 to 2.1 seconds, right? It's falling fast. And so if at 2 seconds it's at 6, it's really not going to fall, have that much more time if you're hitting a stopwatch or something and it's on the ground, okay? We're going to get more precise with this as the unit gets on, with this unit, where I will ask you to actually find that. That's one of your solutions. So, it says, looking at your graph and the table, when does the acorn hit the ground? If we are looking at that, we are going to say, and you don't have to write all of this. Key thing I would probably write, it's going to hit a little more than after 2 seconds. What we're looking for is when the height is 0, okay? So about 2 seconds, because when h equals 0, the acorn hits right after between 2 and 3 seconds. Much closer to 2 seconds than 3 seconds, right? Because what do negative numbers represent in our h column or in our table? If we are thinking about those negatives, and again, I wouldn't write down all of this. Negative numbers would theoretically represent the distance below the ground, right? So negative numbers represent the distance below the ground. So it isn't possible to have that acorn go negative 74 feet below the ground, right? So we're going to kind of ignore those negative values in our real life situations. The last question as we are looking at that. says, well, what is the domain and range of our function? And what do they represent in terms of this problem? So, if we are looking at this, looking at our graph, right? Our domain, what kind of values are we talking about? Time just being what? Is it ever negative? No. And we are looking for time going from 0 up to about what? A little over 2, right? Because we can't have negative values, right? So when we are looking at this, and our range, okay, so when we are looking at this, our domain, the domain is going to go from 0 to a little more than 2. What does this represent in our situation? This represents when the acorn was in the air. Okay? So if we're looking at our domain, 0 to a little more than 2, it represents the time the acorn was in the air. The range, again, it has a definite beginning and end. It goes from 70 as our highest to 0, and it was the height of the acorn.